Hello everyone. In this video we will talk about planar kinetics of a rigid body, work and energy. Now this is going to be very similar to what we covered before when we talked about work and energy, but instead of having, now we have a rigid body, not a particle anymore. So we have to consider the moment of inertia. So let's get started. So T, if you remember from before, was only 1/2 mv squared. Now we have this extra term over here, which is 1/2 ig omega squared. Now this is the general equation. Now let's say we have a body rotating about a fixed point. So we have a rotation, omega, this is O, T is simply 1/2 IO squared. And for a general rotation, general motion, T is 1/2 IIC squared. Now notice here O is actually the same as the instantaneous center because VO is 0. Now let's move on. So as before, we covered in the earlier chapter, T1 plus sum of U1 to 2 equals T2. And doing conservation of energy, we have T1 plus V1 equals T2 plus V2. Now notice in here also for a spring it's the same. The energy is 1/2 Ks squared, and energy of a force is force times distance. It's all the same as we covered before. This is just a continuation. We're just adding the fact that it is a rigid body, so we have a rotation about the center of gravity. Now let's do an example to cover this. We have here a fixed point. Let's call it O. We have G. We have the spring. Okay, this value we have the R 0.5. The weight of this cylinder of this circle is 30 pounds. Now, if you look at this, where is IC? It's going to be the point of contact with the ground. We already covered that before. So let's say we want to find what is the rotation, what is the angular velocity. Now the first thing to do is, what do we know? We have V1, which is 1/2 Ks1 squared, so we have 16 joules. We have V2, 1/2 Ks2 squared, 9 joules. Now T1 is 0 because it starts from rest, and T2 is, as we said before, 1/2 IIC omega squared, or we can use the big equation, but always if you can use the instantaneous center, just do it because it's so much easier. So let's plug in. So we have 1/2 IIC is going to be mass times 0.6 squared. Then the mass now is 30 pounds is not a mass, that's the weight. So we have to divide by G, which is 32.2. And times 0.75 squared omega squared. Now we get from this T2 equals 0.4297 omega 2 squared. Now we apply the conservation of energy. What did that tell us before? T1 plus V1 equals T2 plus V2. Now what do we know? We know T1 is 0. We know V1 is 16 joules. We know T2, this is 0.4297 omega 2 squared, and we know V2 to be 9 joules. So we plug the values in. We have 16 equals 0.4297 omega 2 squared. This is the value that we want, plus 9. So solving this equation, we get omega to be 4.04 radians per second. Now this chapter is actually one of the easier chapters. This kind of, I would say, summarize the whole problem. It's all gonna be, you're gonna be using conservation of energy throughout all the problems, and you might have to use what we learned before, like if you, for example, different ways to get W if we have relative motion and all that. So the best way is to get as much practice as you can. Now, thank you everyone for listening.